Let's look at a particular example. So the scenario is an exploration of the idea that test anxiety may be exacerbated by a number of factors. For example, the item difficulty on the tests could be associated with anxiety, or changing of rooms where students might take a class and hear the lecture in one classroom, but the final exam is changed to another classroom on campus, and as a consequence that may induce a certain level of anxiety. The research question here is, does anxiety change based on the order of easy versus hard questions on a test? Let's glance at the data. The first column is the anxiety after a test, where the students saw the easy questions first, followed by the harder questions. The second column is the same anxiety measure, but for the group that saw the hard questions on the test first. We're going to skip over how the anxiety levels were measured, but that is an interesting question for psychometrics. We will note, though, that a higher score indicates a higher anxiety level. We notice that there are different numbers of participants in each group. While the two numbers in the first row are in the same row, it is important to note that there is no relationship between these numbers, or the individuals from which those scores were obtained. In fact, there is no connection between any of the scores in the first column and any of the scores in the second column. The only shared attribute is within the column. The first group saw the test items ordered from easy to hard, and the second group saw the items ordered hard to easy. Though beyond this, we assume there is no relationship between the individual scores within the columns. We're going to go with what is called the conservative claim. The anxiety levels between the two groups are different. Note, we are not saying one context is more or less likely than the other to result in higher anxiety. Thus, we are just saying there is some difference. It is not uncommon for a researcher to hypothesize that one approach will be more anxiety-producing than the other. And you could run a test with this very question or claim in mind. However, the more conservative approach is to just assume that there is indeed some difference and not hypothesize the direction of that difference. Let's take a different example where we might hypothesize a specific direction. I've heard others claim that students do better on the final if they take the exam in the classroom where they had their lectures. In this case, if we were to conduct a study, we could incorporate this specific directionality of the difference into our claim. In other words, students taking the final in the classroom where they had lectures do better on the final than students taking the final in a room different from where they heard the lectures. So, one of the things that we could explore here is the idea of how many people think anxiety would be worse for the easy to hard group, and how many might think the anxiety would be higher for the questions going in the other direction from hard to easy. And the truth is, while individuals might pose a rationale, there are some people that simply wouldn't be sure. So this is part of the reason why the researchers might choose to go with the conservative approach. For this case, there probably is an argument justifying either direction. And even if the researchers had a specific direction in mind, that isn't researcher bias. That is just part of the scientific process. Bias would be to claim it is true without evidence. Attempting to collect evidence to test your hypothesis is practically the exact opposite of bias. This isn't to say bias isn't introduced into the knowledge-creating process in other ways, but a hypothesis is not in and of itself a sign of researcher bias. Think of it this way. It isn't bias for a researcher to think, if I add these two chemicals, there's going to be an explosion. If they add the chemicals and nothing happens, they were wrong. If they add the chemicals and there is an explosion, hopefully they took the precautions to not get harmed in the resulting explosion. Else, it was nice knowing them. All that said, we can have claims that incorporate directions, and claims that are more conservative, i.e. they just posit a difference but not a direction to that difference. Some might say the latter is less biased, but that is an issue of semantics, unfortunately. So our claim in this case is that anxiety levels are different. So we convert this to the null hypothesis statistical framework, the NHST framework. As this claim does not contain a condition of equality, this claim is best represented as an alternative hypothesis. If we use EH for easy to hard and HE for hard to easy, then we have that the alternative hypothesis is that the average for the easy to hard group is not the same as the average for the hard to easy group. From this, we can write the exact opposite to get the null hypothesis. The average of the easy to hard group is identical to the average of the hard to easy group. So the next question is this a one-tailed or two-tailed test? Because we're looking at a strict inequality, that suggests that this is a two-tailed test. The other way to think about that is if we're looking at the null hypothesis and we're hypothesizing that the values are strictly equal, precisely equal, then we would be surprised by differences that are excessively large in the positive direction And we would be surprised by differences that are excessively large in the negative direction. Thus, we would have critical regions in both tails. Now, in this case, the order doesn't matter. What does that mean, the order doesn't matter? Well, it doesn't matter if it's a two-tailed test. If it's a one-tailed test, then the order does matter. What do we mean when we say the order matters? Well, when I write that they are not equal, I could capture that idea in two equally concise statements. I could say that the average from easy to hard minus the average from hard to easy is not equal to 0. Or we could switch the order of the subtraction and we would have the same result. The average of hard to easy minus the average of easy to hard is not equal to 0. One of the things to attend to, however, in any analysis you do, is to the order of the subtractions. Once you pick the order of subtraction, as long as you keep the same order throughout, then you should be fine in your analysis. But again, in a two-tailed test, this doesn't matter. For a one-tailed test, this difference will either be less than 0 for one order, but it would be greater than 0 for the other order. And this is what we must be careful about when we're doing a one-tailed test. So in that case, the order of the subtraction does matter if we want that difference to be strictly less than 0 or strictly greater than 0.